Physics. General. Motion. How the graph shows that there is no resultant force on the ball. Line on the graph is horizontal, gradient is 0. Therefore, no acceleration, speed is constant. Resultant force causes is proportional to acceleration. Explain what is meant by deceleration. The velocity is decreasing. Change in velocity per unit time. Suggest one reason why the car does not begin to decelerate at t equals 0. Delay in applying brakes or human reaction time. The deceleration of the car is greater than Fm. Because of air resistance or air friction that are acting on the car. The deceleration is not constant. Air resistance resistive force decreases. As speed decreases. As the aeroplane decelerates, its kinetic energy decreases. Suggest what happens to this energy. Thermal energy and in something specific, e.g. brakes, air, tires, or kinetic energy of air. Which feature of a speed time graph shows acceleration? Gradient. Gradient smiley face change of speed time. Explain, in terms of the forces acting on the skydiver, his motion between t equals 0 and t equals 6.0 s. Deceleration because upward force greater than weight or upward resultant force. Air resistance decreases with decreasing speed with time, or deceleration decreases or resultant upward force decreases. Until finally, weight equals air resistance or forces balance or a terminal constant velocity, speed. The ball is released and reaches terminal velocity at point x. Explain the motion of the ball as it falls from rest until it reaches point x. Use ideas of force and acceleration in your answer. Initial velocity increases or weight or force due to gravity acts down, acceleration caused by weight. Resistance of liquid has increased as V increases or force due to air resistance acts up. Air resistance increases as she accelerates or with speed. Acceleration decreases as air resistance increases, resultant force decreases. Terminal velocity reached when downwards force metal ball equals upward force no resultant force. Travels at constant velocity, no acceleration. Explain why the braking distance is proportional to v2. Kinetic energy or time to decelerate is proportional to v. Kinetic energy equals 1/2 mv2 or d equals average v times t equals 1/2 v times t. Work done to lose Ke equals Fd, so stopping distance is proportional to version 2, ORD is proportional to V2. Energy. Principle of conservation of energy. Total energy is constant or initial energy equals final energy. Energy is lost as heat or sound due to friction. Define work done. Work done equals force x distance moved in the direction of the force. Hooke's law. Extension is directly proportional to the load provided that the elastic limit is not reached. Explain what is meant by the term limit of proportionality of the spring. Extension is proportional to load. Up to the limit of proportionality, extension proportional to load. Explain, in terms of the work done, the energy change that takes place as the trolley slows down. Work done against friction or K of trolley used to do work. K decreases to 0. Thermal energy produced. Why the value calculated in X is different from Y. Work done against friction. Thermal energy generated. Momentum. State the principle of the conservation of momentum. No external forces or isolated system B1. Sum of momenta total momentum remains constant. Explain how this principle applies to the accelerating rocket and the exhaust gases. Rocket gains upward momentum B1. Ejected gas gains equal quantity of momentum in opposite direction or momentum of gas decreases by equal amount. Power. Suggest and explain the effect of this increase in mass on the operation of the conveyor belt. Increase in PE of mass is greater. WD greater. T equals EP and power is constant. Speed reduced, time taken is longer. Moment. Explain why the bus begins to topple. Line of action of the center of mass falls outside the base of the bus or anti-clockwise moment is greater than clockwise moment. Explain how the counterweight prevents the crane from toppling over. Provides anti-clockwise moment M1. Total clockwise moment equals total anti-clockwise moment or resultant turning effect equals 0. Thermal. Thermal energy transfer. Ways to reduce heat loss, larger final temperature. Black color is a good heat absorber and of infrared radiation. The insulating material and trapped air are good insulators which reduces or prevents heat loss of the water into the surroundings. Copper and metals are good heat conductors. Glass trapping of air reduces convection, warm air being blown away. Glass produces greenhouse effects. How a vacuum flask keeps a liquid cool during a hot day. Any mention of radiation, infrared radiation WRT silvered surfaces B1. Silvered surfaces are poor emitters, poor absorbers, good reflectors. Glass is a poor conductor. Or glass reduces thermal energy, heat gain by conduction. B1. Vacuum prevents thermal energy, heat gain by conduction. Or convection. B1. Stopper reduces thermal energy, heat gain by convection. B1. Shiny surfaces reduce the power that needs to be supplied to keep the oil at the correct temperature. Shiny surfaces are poor emitters of radiation. B1. Infrared radiation mentioned. B1. Less energy lost or lost energy does not need to be supplied. B1. Describe, in terms of molecules, how thermal energy is transferred from the heated sand through the base of the plastic pot. The sand molecules gain K or hit other molecules when heated or transferred by conduction. Energy is transferred to molecules of plastic pot in contact with sand through collisions. Or energy or lattice vibrations transferred to neighboring molecules. Explain, in terms of the atomic lattice and electrons, how thermal energy is transferred through the aluminium. Lattice vibrations are faster. The atoms pass on energy to other neighboring atoms by collisions. Atoms pass on the energy to electrons. The electrons move through the lattice. Explain how electrons transfer thermal energy through the metal of the can. Atoms, ions vibrate. Vibrating atoms, ions hit electrons. Electrons propelled, traveling through metal, moving through metal. Electrons hit distant atoms. Free electrons, delocalized electrons mentioned. Describe how energy from the sun reaches the earth and warms the road. Radiation. Light, infrared, electromagnetic radiation. Travel through space, vacuum. Absorbed by road. Explain how convection produces this breeze. Density of the air above the road decreases. Air rises. Air replaced by cool air. Explain how using the holder makes it more comfortable to hold the cup. Air is a good insulator. The holder reduces conduction. The temperature of the outside of holder is lower than the cup. Explain how a lid reduces the rate of cooling more effectively. Less convection, evaporation from the surface. Molecules. Motion of molecules of gas. Collide each other. Randomly. At high speeds. The air above the road is heated by the warm road. Describe how this affects the molecules of the air. The molecules gain kinetic energy. Move further apart. Explain, in terms of forces and the motion of air molecules, the cause of the motion of the smoke particles. Air molecules bombard smoke particles. Air molecules are very small. Are fast moving. Move in random directions. Collisions exert unbalanced forces on smoke particles. Explain, in terms of molecules, why the internal energy of the air increases. Kinetic energy of molecules has increased. Explain, in terms of molecules, why a liquid expands when heated. Molecules speed up or gain K. Molecules move further apart or push others away. Explain, in terms of molecules, why a liquid expands when heated. Molecules speed up or gain K. Molecules move further apart or push others away. Explain, in terms of molecules, why a liquid expands more than a solid when heated. Forces between liquid molecules weaker than in solids. Less energy, work done to separate molecules or greater separation for same work done, same increase in energy. Explain, in terms of forces between molecules, why gases expand more than liquids when they have the same rise in temperature. The average distance between molecules greater in gas, easier to increase separation of gas molecules. Attractive force between molecules lower in gas. Describe, in terms of molecules and their motion, how a liquid differs from a gas. Molecules close are. Molecules move only small distances between collisions or do not move freely. Molecules move in clusters or slide past each other. Solids have a fixed shape. Liquids adapt to the shape of their container. Gases fill their container. Explain in terms of forces between molecules and arrangement of molecules, why solids, liquids and gases have these properties. Solids, molecules in lattice arrangement. B1. Solids, strong forces between molecules. B1. Liquids, molecules not fixed in place or molecules have an irregular arrangement or molecules slightly further apart, on average, than in solids or spaces between the molecules. Liquids, average forces too weak to keep molecules in a definite pattern or forces just enough to hold molecules in the bulk of the liquid. Gases, molecules far apart. B1. Gases, weak, no forces between molecules except during collisions. Physical processes. Melting. Molecules absorb K, able to overcome the FOA holding them together. Molecules must be separated or intermolecular bonds must be broken, overcome. Work done against bonds, or energy is required, needed, not increase of K, speed. Evaporation. Molecules do work against attractive force as they evaporate. More energetic molecules more likely to escape from the surface of the water. Average speed of molecules decreases. Temperature is related to the speed, energy of the molecules, or fewer energetic molecules remain in water. Temperature of liquid decreases because average Ke of remaining molecules is lower. How sweating helps cool your body on a hot day. Thermal energy in the skin, body transferred to molecules of sweat. These molecules have enough K to escape from the skin, become water vapor, leaving behind molecules with lower energy, so remaining liquid is cooler, which leaves the skin, body at a lower temperature. Temp decreases. Conditions to help the wet clothes dry more quickly. Air temperature increases. More wind. Cloud stops covering the sun. Less windy weather. Produces a smaller pool of water more slowly as a draft over surface removes water vapor, enabling faster rate of evaporation. More windy. Great fast evaporation of sweat as wind blows fast moving molecules away, or molecules do not re-enter the liquid. Boiling. Describe what is meant by boiling point. Temperature at which liquid becomes a gas, or liquid and gas exist together. Eventually, the water reaches boiling point. Thermal energy from the hot plate is still being transferred to the water. Explain, in terms of molecules, the effect of this thermal energy on the water. The molecules escape from the liquid. Bonds are broken. Molecules gain Pe or Wd to break bonds. Pressure. How pressure created. Air molecules collide with the walls of the inner surface. Momentum of a molecule changes. Momentum equals mass x velocity. Force exerted, impulse or force equals rate of change of momentum. Force spreads over area, surface or pressure equals F(a). Why surface area matters. Pressure equals force area or except P inversely proportional to area. Same force exerted by each group of books. Area in contact with bookshelf in group B is greater, or area in contact with bookshelf in group A is smaller. Why is a greater pressure exerted with an increase in temperature? Collide W walls more often, creating a bigger pressure. Greater force per unit area. Why does the volume of the container decrease as the temperature increases? Molecules move more slowly, have less kinetic energy. Pressure inside balloon decreases, or pressure is directly proportional to temperature, or P proportional T. Volume is directly proportional to temperature, or V proportional T. Molecular collisions less frequent. Molecular collisions less violent, hard, exert smaller impulse. Water external pressure compresses balloon, or water pressure greater, and balloon compressed. Explain what happens to the pressure of a constant volume of air when the temperature of the air increases. Use ideas of momentum of molecules in your explanation. Molecules move faster, or their K increases. Molecules have greater momentum. Molecules collide with walls of container and change momentum. Greater change of momentum when temperature is higher, or collisions more frequent, or harder collisions with walls. Hence higher pressure. State and explain, in terms of molecules, any change in the pressure of a gas when the volume is reduced at a constant temperature. Molecules travel shorter average distance between collisions with walls, not molecules change speed. Molecules hit walls more often, or more collisions per unit area with walls. Greater force, or greater rate of change of momentum of molecules per unit area on walls. The gas bubble rises to the surface. The volume of the gas bubble increases as it rises higher in the water. Pressure in liquid increases with depth, or pressure decreases. Pressure of gas is inversely proportional to volume, or internal pressure greater than external pressure. Suggest and explain the effect of air has on the operation of the hydraulic press. Paper is not compressed as much. Some of the energy is used to compress the air instead of the paper. Explain, in terms of molecules, why liquids are very difficult to compress. Molecules close, molecules touching, or no space between molecules. Repulsive intermolecular forces every large. Explain why the pump must exert an increasing pressure on the oil as the depth of the oil increases. Pressure increases and the depth increases. To keep the upwards force constant to lift the oil to oppose the increased pressure. Thermal capacity. Define. Quantity of thermal energy or energy to increase the temperature of an object per degree Celsius. Why the SHC of sand may be different from the value calculated in X. Sum of energy supplied by the heater heats the heater goes to lagging goes to surroundings M1. Specific heat capacity is lower than value in X. The temperature of the sand on a beach is much higher than the temperature of the sea. Explain why. Specific heat capacity of water is much higher than specific heat capacity of sand. Same rate of energy supplied to sand and sea. Waves. Diffraction. Why a car radio may pick up low-frequency radio signals but not pick up high-frequency radio signals when the car is traveling behind a hill. Bigger wavelength, low frequency. Diffract more. Suggest why light waves from a television are not diffracted through doorways but sound waves are diffracted. The wavelength of light is much shorter than the width of the doorway. The wavelength of sound is similar to width of the doorway or lambda tilde equals width of gap for diffraction to occur or larger wavelength results in greater diffraction. Much wider gap. How will the pattern of wave crests differ? Waves pass through gap remaining straight. Less no diffraction occurs. Total internal reflection. State and explain the use of optical fibers in medicine. Description of fiber passing to site to be examined treated. Light passes down fiber to site, and image returns to sensor observer, or alternative use to endoscopy. Extra detail, e.g. laser light source, illuminated organ, image, camera, type of sensor. Describe and explain the action of optical fibers in communication technology. Light infrared travels in fiber. Total internal reflection at inner surface or within graded index fiber. Light carries information, signal, data, message or signal, light encoded. Describe what is observed during total internal reflection. Wave light ray is completely reflected at the boundary between two mediums, or no refraction or no wave light ray passes into second medium, across boundary or only reflection occurs. State two conditions required for light to be totally internally reflected. Light must pass from medium where it travels slower or to medium where it is faster or from medium with larger refractive index or to medium with smaller refractive index. Angle of incidence must be greater than the critical angle. Explain the term TIR. Light traveling from optically dense medium to optically less dense medium. All light reflected or no light refracted. Angle of incidence is greater than the critical angle. Refraction. Explain why the direction of the wave fronts change because of refraction. Speed changes. Wave speed is smaller in right-hand part of tank or waves slow down or bottom, on the page, section of wave hits the boundary first. Bottom, on the page, one part of wave slows down first, and different sections are delayed by different amounts. Idea of one side of wavefront enters, hits solid first or wavefront does not all hit the solid all at once, B1. Idea of this side slowed down first or this side delayed relative to other side B1. Angle of wavefront changes or different parts of wavefront delayed by different amounts.